about reinforcement-based regularization hyperparameter controlling for facial expression recognition. And these are the contents. And first, we need to understand what the MPR is. Simply, it is just to use facial expression for classifying the emotion. And for training the classification model, we need just the training dataset loss function and gradient discount for minimizing the training loss. And for validation, we need the validation dataset and desirable metrics. And our task is just to find the model that performs the best on the given metric. And for the training classification model, two kinds of data can be used. First one is the general FPR dataset, and second one is the in-the-wild FPR dataset. General FPR dataset is collected from the control settings such as repertoire, and in-the-wild FPR dataset is collected from the natural setting. As a advantage of the general FPR dataset, it is possible to generate infinite number of samples. However, when that dataset is used for training classification model, there is a performance gap when this model is deployed in the practice because of the different distribution of data set between general FPR dataset and real-world dataset. However, in the case of the in-the-wild FPR dataset, there is a minimal discrepancy between the distribution of dataset. However, as a limitation, it is impossible to collect the in-the-wild FPR dataset beyond certain amount. So there is an issue of overfitting, and that is the key obstacle for training classification model. And overfitting is just about the phenomenon where the performance gap between on the training dataset and validation dataset becomes larger. And for remedy for the overfitting, the regularization is conventionally used, and the regularization technique is used for training. Is used during the training classification model. And if you see the improvement on the right figure, there is a increased amount of validation metric performance. And as a type of the regularization, there are a bunch of regularization, but you don't need to know about just the kind of the regularization. The important topic in my thing is the regularization hyperparameter. And there is a question of how can we control the regularization hyperparameter, because this hyperparameter is quite important for training classification model. It is necessary to delicately control the regularization hyperparameter. So still, until now, that was the introduction, and my theme starts from here. And as mentioned, hyperparameter control is quite important, and there are three branches: static, scheduler, adaptive. As you see, the static fixes the regularization hyperparameter, and scheduler uses a certain rule or predefined schedule for controlling regularization hyperparameter. However, in the case of adaptive, the hyperparameter is decided in response or according to the status of the model being trained. And these are just the basic framework of the adaptive hyperparameter. If you see the sequence, the training is performed with the selected regularization hyperparameter, and the metric from the model is collected. And this information is used for certain function, and the regularization hyperparameter is decided. And this selected regularization hyperparameter is used again, is used yearly, and this loop is repeated. So this is the basic framework. And my method inherit this concept. So my method follow this sequence also. And my novelty or the difference of my method is the introduction of the agent that decide the regularization hyperparameter that can reduce the overfit. In other words, it is the main point of my method is the agent that predict the regularization hyperparameter that is expected to be reducing overfitting. And then next question is how can you train this agent? And the answer is reinforcement learning, but it's too complex to present here. So I think in terms of the optimization, I think in this presentation it is enough to guide the objective function of agent. But still, this is too complex. So simply saying, the objective function or purpose of agent network is to minimize the gap between the training and validation metric of classification model. So my main point is that the agent that predict the regulation hyperparameter that is expected to be reduced or fit. And this is the example of my framework, and you can see the right figure showing the selected regularization hyperparameter based on the reinforcement learning optimization. And you can see the performance in perspective of classification model. It is quite weird phenomenon where the validation accuracy outperforms the training accuracy, but it is designed. And this is the actual result showing this graph. And as some more example to check whether my framework is effective or not, it is possible. There is some concept of GradCam, which show the area that model focus on for their prediction. So you have to pay attention to the red and blue. Red is the area the classification model use for prediction, while the blue is not. And the yellow is between the red and blue. So if we see some strategy of scheduler strategy and train the classification model based on that approach, we can see the baby, and the results show that the bubble around the face is used for prediction because there is a yellow. However, if my method is utilized, the bubble around the face is not used. Just facial information relevant to the emotion are used only. So that was the main difference when my method is used or not. And still, until now, there was just a sample, and for getting objectiveness, this is just experiment design. I use regularization such as dropout noise injection, and the comparison is conducted on the static scheduler adaptive. And for more diverse data set, I use a 3 classification data set. And these are just results showing that objectiveness my lesson. So this was my presentation.